are looking at is vectors and operations with them. First thing you need to know is what a vector is. So it's a directed line segment involving magnitude and direction. The first letter is the initial point, and the second is the terminal point. Okay, it looks kind of like an ordered pair, except instead of parentheses, we have these brackets around it. We are mostly going to focus with the position vector, where it starts at the origin. So I'll give you a few minutes to jot all that stuff. So our focus is this position vector, which is usually denoted with a bold U. And then we have this A and B within that. The position vector starts at the origin. So it's saying you have a graph starting at the origin and ending at the point AB. So for our case today, when we're looking at these vectors, because we are looking at the one particular type, the position vector, that AB in there is just a point on this vector. So we have a lot of information about vectors we're going to look at today, and it's all actually very, very similar to stuff we already know. It's just written a little bit differently. So we're going to talk about the magnitude of the vector. Magnitude is denoted with two vertical bars. That bold U means we're talking about the position, or the position vector, so starting at the origin. And it gives us this formula for how to find it. If you think about this, okay, I told you that AB is just the endpoint. If instead I had called that X and Y, and we thought about it in terms of triangles, your horizontal is your X, your vertical is your Y, and we used to call this R, didn't we? And when we solved for R, we said X squared plus Y squared equals R squared. So R was the square root of X squared plus Y squared. It's the same thing, except they're using A and B instead of X and Y. Okay, so it's just talking about the length of that vector. And since it's centered at the origin, it's just from the Pythagorean theorem. It talks about the direction angle. So if I wanted this angle here, well, it tells us tangent of theta equals b over a. If you want to think about what we already know, tangent is opposite over adjacent. So b is like your y and a is like your x. So it's nothing that we haven't done before. It's just written differently in this. They use a's and b's instead of x's and y's. Okay, so our first example. I want to find the magnitude and direction for this vector. So magnitude is just the length of the vector. So if we use our formula, it's the square root of a squared plus b squared. So my magnitude is radical 30. Then I need my angle. So to find the angle, we will use tangent. Tangent is y over x, so -2 over 3, or b over a, if you're using that. Okay, if I drew this, 3 -2 is in what quadrant? The fourth. So we need to be in quadrant 4. Reference angle. I need to know when tangent is equal to 2/3. So let's go to the calculator. Degree mode. So we'll do tangent inverse of 2/3. And we get 33.69 degrees. So to place that angle in quadrant 4, what do you do? No, I just don't know what you said.
I was just gonna say, go over the
Oh. We want like this angle. We found this little piece is 33.69. How do I get the other? Just like every other time. If it's in the fourth quadrant, you do 360 minus that. So 360 minus 33.69 gives you 326.31 degrees. So we found our magnitude and our direction. Questions there?
So we're just trying to find the angle. Is that all we're trying to do with this?
Well, depends on what I ask for. I asked for magnitude is the length of it. When I asked for the direction, that's asking for the angle. Okay. The next thing I might ask you to do is we can talk about horizontal and vertical components. You know, how far do you move horizontally or vertically in these vectors? So they are given by this formula. This tells how your A and B are found. Your A is your magnitude times the cosine. Of your angle. And your B is your magnitude times the sine of your angle. That shouldn't be too surprising if you think about the x value of your ordered pair. If you're on the unit circle, x is cosine and y is your sine. So that's the cosine is multiplied with the magnitude to get your x. The sine is multiplied with the magnitude to get the y. So let's use that to find this problem. And make sure you're writing all these down because your homework is just like this stuff. You need these formulas. So vector W has a magnitude. So magnitude looks like absolute values. It's just telling you the length of it. Of 25.0. Our direction angle is 41.7 degrees. Find the horizontal and vertical components. So your horizontal is like your x, which in this case is denoted with A. And we find it by doing the magnitude times the cosine of your angle. So we have 25 times the cosine of 41.7. And we get, let's just round to 3 significant digits, 18.7. This is for any particular vector, not necessarily a position one, so not one starting at 0, 0. This is how they're found if they're starting at a different place. So the vertical component, vertical is like your y, so that's our B. That'll be the magnitude times the sine of theta. So magnitude 25 times the sine of 41.7. And we get 16.6. So that is our vector. Vector W, the x part of your vector is like your horizontal component. Your y part is your vertical component. So that's how a vector can be found. You have to know the length of it and the direction. Any questions there? Let's write vectors from a picture. So each vector needs to be written in the form AB. And we have three different vectors here, U, V, and W. So let's start with vector U. This tells me that in vector U, the magnitude, what was the length of that vector in my picture? 5. What is the angle in that picture? 60. So to get the vector U, you do the magnitude times the cosine of your angle for the x, magnitude times the sine of your angle to get the y. It's just your vertical and horizontal components. What's the cosine of 60? And what's the sine of 60? So vector U is 5 halves, 5 radical 3 over 2. So all you need to write the vector is the length and the angle. So let's do V. This is V. What is the length of V? 2. What is the direction for V? 180 degrees. So V would be 2 times the cosine of 180, comma 2 times the sine of 180. Cosine of 180? Sine of 180? So vector V is -2, comma 0. Last one, we have vector W. So if I'm looking at W, its magnitude is 6. Direction, so the angle for W?
280.
So W is 6 times the cosine of 280 degrees, 6 times the sine of 280 degrees. 280 is not from our unit circle, that means we use the calculator here. So 6 cosine of 280 gives us 1.0419. 6 sine of 280 is -5.9088. So we've talked about magnitude, talked about direction, and then how to write your vectors, or also known as the horizontal and vertical components. Any questions about this?
No, I'm kind of trying to figure out from the last one.
Uh-huh.
You have the magnitude
Mhm.
equals
The 6, which I just got from my picture.
right.
And then the angle here was from the origin all the way to that point. That's the 280.
Okay. Okay. Then you just stuck it in the calculator.
Yes. Anything else? Last thing I want to talk about are some operations with vectors. So, with vectors, we can add and subtract just like normal. If I have vector AB plus vector CD, it does what you think. Your final vector, the first component is A plus C, second is B plus D. We can also take them times a number. So you get KA times KB. We're not going to talk about multiplying these vectors together today. We're just doing some of our basic operations. You could also subtract them. You just do the first minus the second. So let's do an example where we practice that, and then I'm done. So my vectors. U is the vector -2, 1. And V is the vector 4, 3. So A, if I want U plus V, so vector U plus vector V, what do you get? I asked you to illustrate. Really, you can think of this like ordered pairs. -2, 1 looks like this. A vector typically, though, doesn't end with a dot, it ends with an arrow. So that's vector U. Vector V was 4, 3. And then when I did U plus V, I got 2, 4. So that's the U plus V vector, which kind of makes sense from the picture. It's in between them when you add those together. Second one, -2U just means -2 times the -2, 1, and we get 4, -2. Once we plotted it, the original vector U was here. I took that times -2. We got this one. opposite direction because it was multiplied by a negative twice as long because we doubled it. Last one, 3u minus 2v. So 3 times u minus 2 times the v. So this 3u would give me a negative 6, 3. You might change this to a plus and then distribute a negative through the second one, so that becomes negative 8, negative 6. If we add those together, we get negative 14, negative 3. So those are the only operations we're doing, and they are exactly as you would expect. You just add or subtract the corresponding pieces. Do you guys have any questions for me? So that's really the end of what I wanted to talk about in this section. So you can have the rest of the hour to work on this assignment.